How does this work? Hi, I'm Archimedes. I am a Greek mathematician, physicist, engineer, inventor, and astronomer. This is the beginning of my video diary, and I'll be talking about all the findings I found in my life. And if you like this video, please subscribe, rate, and like this video. Okay, so I found this really nice job today that King Harold II has told me to do. King Harold II gave pure gold to a goldsmith, but believes that he used the gold to his own personal use and didn't use the gold to make it into the crown, but not all of the gold, only partially. So my job is to find out how much gold he used and how much silver he applied to the crown, but I cannot break it apart or mold it in any shape or form of the crown. So this job is really difficult, but I think I can do it. Alright guys, I really figured out how to figure this out. Okay, so while I was taking a bath, because it's really hot outside, and then I noticed once I got to the bathtub, the water would rise, and then I could use that to determine the volume of the crown. And then as that happened, I was so excited that I ran outside, naked, yelling out "Eureka" to the king.
Okay, so he determined the volume of this irregular shaped object because for practical purposes, water is incompressible, so the submerged crown would displace an amount of water equal to its own volume. By dividing the mass of the crown by the volume of the water displaced, the density of the crown would be obtained. The density would be lower than that of gold if cheaper and less dense metals had been added, such as silver and copper and such. Archimedes discovered that silver had indeed been mixed in.
Okay, I found something really exciting, like so exciting. Okay, so I proved that the volume and surface area of the sphere are 2/3 of the cylinder. Isn't that so exciting? I just want to put it on my tomb right now, like when I'm dead.
Okay, so Archimedes discovered that the volume is 4/3 pi r cubed for the sphere and 2 pi r cubed for the cylinder. That's the volume. And the surface area for both is, he discovered, 4 pi r squared for the sphere and 6 pi r squared for the cylinder, including the two bases. So from those, he discovered that the volume and the surface area of the sphere is 2/3 of the cylinder.
Okay, I found another interesting point about the correlations between circles, and later I used contradictions, which is called double reductio ad absurdum, which is the proof by contradiction, and then I later found the area of a circle, which is pi r squared, using right triangles.
So he started off with inscribing a square into the circle, which is composed of two right triangles with the same diameter as the circle. He found the area of the two right triangles over the square and figured that it wasn't accurate because there's still some area left over outside of the square. So he moved to inscribing a hexagon into the circle, and he discovered that it was more accurate because instead of it being right triangles, the triangles here are instead equilateral triangles with the radii being equal. He then still couldn't figure out the true area of the circle because there was some area left over on the outside once again. So he discovered that adding more sides or more triangles inside, like the thinner triangles, it created a more accurate effect because the more triangles and thinner they are, the closer it gets to the circumference of the circle. After that, he just added as many as it would fit in the circle, and then he found the area of the circle.
Okay, I found something really interesting today.